April 6, 1945. Kanoya Air Base, Japan. Vice Admiral Matome Ugaki stands motionless on the tarmac, the humid afternoon air heavy with the sharp, metallic scent of aviation fuel. He quietly draws on a cigar, his eyes fixed on the horizon. Above him, the sky is physically vibrating. Nearly 700 warplanes are tearing through the clouds, their engines roaring in a deafening, unified symphony, heading straight for the American fleet anchored off Okinawa. This is Operation Kikusui. The orders handed down to these young pilots were absolute, carved in the ancient traditions of their ancestors. There will be no return trip. They are to drive their machines through the American steel, whatever the cost. But just hours later, the radio room at Ugaki's command center descends into utter chaos. The reports filtering back are fragmented, panicked, and mathematically impossible. Hundreds of Japanese planes had successfully slipped past the American fighter patrols. They had the U.S. warships dead in their sights. But before a single pilot could push his stick forward to dive, before they could even arm their bombs, their aircraft disintegrated in mid-air. The few survivors who somehow limped back to base brought a chilling revelation. The American anti-aircraft gunners were missing. Their artillery shells were flying wide, completely missing the Japanese planes by 50, sometimes 70 feet. There was no physical impact, no metal tearing into metal. And yet, every single time an American shell flew past a Japanese Zero, the sky would violently erupt. It was as if an invisible wall of death had been erected over the Pacific. The top brass of the Imperial Japanese Navy began frantically tearing through their tactical maps. They interrogated mechanics. They hunted for spies in their own ranks. They desperately searched for an explanation for the dark magic that was shredding their empire's air power. They would never realize that the United States Navy was firing miniature, self-contained radar stations out of their artillery barrels. A military secret so profoundly guarded and so devastating that for most of the war, American soldiers were strictly forbidden from ever using it over solid ground. Today, we are going to look inside the psychological collapse of the Japanese High Command as they slammed headfirst into a weapon that broke every law of physics they thought they knew. To truly understand the absolute shock that paralyzed the Japanese Admiralty in the final year of the war, we have to understand the sheer arrogance that built their empire. Men like Ugaki, and those in the high command, operated on a naval doctrine known as Kantai Kessen, the decisive battle. It was a philosophy steeped deeply in the samurai spirit. They believed, down to their very marrow, that while American ships might be large and American factories might be loud, the American sailor lacked the spiritual fortitude for a war of attrition. They believed that Japanese skill, combined with an unflinching willingness to die, would always overcome American steel. And in the early years of the war, their confidence was not entirely misplaced. It was grounded in cold, hard, bloody mathematics. To truly grasp the nightmare of the early Pacific War, you have to stand in the boots of a 19-year-old American anti-aircraft gunner in 1942. Imagine the deafening roar of a naval battle. The deck is slick with oil, sweat, and seawater. An incoming Japanese Ichi-D-3A dive bomber, the infamous VAL, is plummeting toward your ship at a near vertical angle. You are not just pointing a gun and pulling a trigger. You are fighting a desperate, losing war against time itself. Deep in the bowels of the American cruiser, well beneath the waterline, sat the plotting room. It was a claustrophobic, heavily armored steel box, smelling intensely of hot oil, electrical ozone, and terrified sweat. Inside this cramped space, a team of young sailors frantically cranked the heavy steel dials of the Mark 37 fire control system. This was not a modern digital computer. It was a massive, mechanical analog beast made of thousands of interlocking brass gears, cams, and shafts. These men were trying to solve a three-dimensional geometry problem in real time, while their own ship violently pitched and rolled in the heavy ocean swells. Up above, a sailor exposed on the deck looked through an optical rangefinder, desperately shouting coordinates down a communication tube. Down below, the men in the plotting room fed those numbers into the churning mechanical beast, trying to predict exactly where a Japanese plane, plummeting at 300 miles an hour, would be in exactly 4.5 seconds. The machine spit out a fuse setting. Up on the exposed deck, surrounded by the cacophony of exploding bombs, a loader had to physically grab a heavy 50-pound artillery shell. He shoved its nose into a mechanical fuse setter, forcefully turning it to match the exact fraction of a second, commanded by the men down below. If the loader's sweaty hands slipped, if the transmission from the rangefinder was delayed by a single heartbeat, if the Japanese pilot simply pulled back on his flight stick and altered his altitude by a mere 100 feet, the entire mathematical equation instantly fell apart. The loader would ram the shell into the breech. The gun would fire. The American shell would detonate exactly when it was supposed to, 4.5 seconds later, but the Japanese plane was simply no longer there. The American gunners would watch, their hearts pounding in their throats, in absolute agony. They would see their perfectly calculated artillery erupt as a harmless, impotent puff of black smoke a quarter-mile behind the enemy tail. They were fighting a modern, high-speed aerial war, using weapons that still relied on the stopwatch and the slide rule. The physical and mental exhaustion was absolute. The terror of watching an enemy plane survive a barrage of 1,000 heavy rounds, steadily growing larger and larger in the crosshairs, was a trauma that haunted American sailors long after they returned home. The Japanese commanders knew all of this. They had studied the American hit rates meticulously. They knew the severe limitations of the Mark 37 director. They knew the American mechanical fuse setters were simply too slow for the speed of modern combat. And they built an entire naval doctrine around that agonizing American slowness. This mathematical reality was the bedrock of Japanese naval strategy. The admirals knew the Americans would miss. Their battle plans were entirely predicated on the concept of acceptable blood loss. If they sent 50 bombers against an American aircraft carrier, they fully expected the clumsy American anti-aircraft fire to swat 10 of them out of the sky. They did not care about the 10, because they knew the remaining 40 would easily pierce the defensive screen, drop their payloads, and turn the pride of the U.S. Navy into a burning, sinking tomb. They viewed the lives of their pilots as currency, and they were more than willing to spend that currency to buy a victory for the emperor. But as the war dragged into late 1944 and early 1945, the Japanese leadership doubled down on this exact same formula. They hurled massive formations of their finest remaining aviators into the Philippine Sea, and later toward Okinawa, expecting the same mathematical exchange of blood for time. They were blind to the quiet revolution happening in American laboratories. They had absolutely no idea that the United States of America had entirely rewritten the laws of physics and the rules of engagement. When the surviving pilots began returning to Japanese airfields from the bloody skies over Okinawa, the atmosphere inside the Imperial command centers shifted from supreme confidence to a suffocating, paralyzing confusion. The debriefing rooms were thick with cigarette smoke and disbelief. But these were not places of tactical review. They had become draconian tribunals. When the few shattered remnants of the strike forces landed their bullet-riddled planes, they were not greeted by cheering crowds or sympathetic medics. They were immediately met by the Kempeitai, the feared and utterly ruthless Imperial Japanese military police. These young pilots had just witnessed a technological massacre. They had watched their friends vanish in clouds of fire. But their own government viewed their survival with deep, paranoid suspicion. In the Imperial Japanese Navy, to return from a strike mission without your squadron, having failed to damage the enemy, was a mark of profound dishonor. The Kempeitai isolated the survivors. They placed them under blinding interrogation lights, treating their own elite aviators not as heroes, but as suspected cowards and traitors. The pilots, their hands still trembling from the adrenaline, desperately tried to explain the unexplainable. They swore, on their honor and the lives of their families, that they were easily dodging the American artillery fire. They reported that the shells were completely missing them. But as the munitions flew past, missing by the length of a city bus, black clouds of shrapnel would spontaneously erupt in thin air. They described an American fleet surrounded by an impenetrable, self-aware wall of exploding iron. The Kempeitai officers sneered in their faces. Men of high rank, men who had spent their entire lives studying the precise physics of naval warfare, do not simply accept that magic has entered the battlefield. They turned their fury onto the pilots themselves. The interrogators accused this new generation of aviators of being terrified of the heavy American flak. They accused them of dropping their bombs in a panic from high altitudes, turning tail, and inventing ghost stories about self-exploding shells to save their own skin. To the old guard, it was far easier to believe that their men had lost their samurai spirit than to accept that the enemy had built an impossible weapon. But the death toll continued to climb. Whole squadrons were being vaporized without ever putting a scratch on the American hulls. When the losses reached into the hundreds, and then the thousands, the relentless interrogations stopped. Denial curdled into a deep, rotting paranoia. Vice Admiral Matome Ugaki, the man overseeing the Kamikaze campaigns, meticulously documented his growing despair in his personal diary, later published as Fading Victory. Reading his entries from the spring of 1945 is like watching a man slowly lose his grip on reality. Ugaki sat in the sweltering heat of his concrete bunker, listening to reports of his most elite veteran pilots being swatted from the sky without ever dropping a single bomb. If the pilots weren't lying, then there was only one logical conclusion left to the Japanese high command. The Americans knew exactly what they were going to do before they did it. The paranoia swept through the Imperial Navy like a plague. They convinced themselves that their sacred naval codes had been completely compromised. They believed American intelligence was intercepting their flight plans in real time, calculating the exact altitude, speed, and approach vectors of every single Japanese squadron, and relaying those precise coordinates to the gunners on the ships. How else could the Americans perfectly set a time fuse to explode at the exact moment a Japanese plane flew by? They tore apart their own mechanics' quarters. They hunted relentlessly for spies and saboteurs within their own bases. They changed codes, altered flight paths, and executed sweeping purges of their own intelligence networks. Some officers in the high command even began to whisper absurd theories, suggesting the Americans had secretly developed a death ray capable of melting aircraft engines from miles away. But no matter what they did, no matter how many codes they changed, a lethal canopy of iron continued to slaughter their men. They were bleeding to death in the dark. We often romanticize war through the eyes of the soldiers holding the line in the mud, or the pilots pulling G-forces in the cockpit. But the true cold brutality of war sometimes lives inside the soundproofed walls of a command center, where a general stares down at a map, realizing that the lives of thousands of young men under his command have just been erased by a mathematical equation that he will never, ever be able to solve. The despair that gripped the Japanese Admiralty was matched only by the incredible salvation happening on the decks of the American fleet. This invisible shield was doing more than just destroying enemy planes. It was creating a canopy of life over the Pacific. Because of this technology, tens of thousands of young American sailors, boys from farms in Ohio and factories in Michigan, survived the most terrifying aerial onslaught in human history. They survived the dive bombers. They survived the kamikazes. They got to go home, build lives, and raise the families that built modern America. The silent sacrifice and brilliance of America's greatest generation saved thousands of sailors and brought them safely back to our shores. These authentic, hard-fought stories of history deserve to be remembered forever. If you appreciate preserving these moments in time, I ask that you please take a brief second to leave a like on this video. Your genuine support is the only thing that allows me to keep digging deep into these untold chapters of our past. The agonizing truth that the Japanese command was desperately searching for had nothing to do with spies, or broken codes, or death rays. The answer lay 8,000 miles away in the quiet brick-lined laboratories of Johns Hopkins University and in the bustling grease-stained factories of the American heartland. There was no magic. There was only the raw, unmatched industrial and intellectual might of the United States. The project was designated Section T, and in terms of absolute secrecy, it was guarded with the exact same lethal intensity as the Manhattan Project that was simultaneously building the atomic bomb. The problem the Americans had set out to solve was considered, by most of the world's leading physicists at the time, to be borderline science fiction. The concept was simple, but the execution was maddening. The military wanted to take a radar station, a massive piece of equipment that usually required the space of a small building, shrink it down to the size of a pint of milk, and stuff it into the nose cone of a 5-inch artillery shell. But that wasn't the hard part. The true impossibility of the VT, or variable time proximity fuse, was the physics of the gun barrel itself. Inside that tiny radar station were miniature vacuum tubes. These were delicate, fragile instruments, made of thin glass and wire, practically identical to the bulbs sitting in the radio console in your living room. When a 5-inch shell is fired from a naval gun, the violent explosion inside the breech subjects the projectile to a staggering force of 20,000 Gs. That is 20,000 times the force of the Earth's gravity. Simultaneously, the rifling in the barrel spins the shell at 500 revolutions per second. Under those nightmarish forces, glass shatters into fine dust. Wires snap like dry twigs. Circuit boards are crushed into powder. The man tasked with solving this impossible puzzle was a brilliant physicist named Dr. Merle Tuve. When Tuve was first handed the assignment, conventional military engineers laughed at him. Putting a glass vacuum tube inside an artillery shell was considered a fool's errand. It was like putting a delicate porcelain teacup inside a bank vault, blowing up the vault with dynamite and expecting the teacup to survive without a scratch. Tuve knew he couldn't use standard radio parts. He needed something incredibly small and unimaginably tough. He found his answer in the most unlikely of places, the civilian hearing aid industry. Companies that manufactured hearing aids had already perfected the art of creating microscopic, durable vacuum tubes. Tuve brought these miniature tubes into the lab. To test their durability, he didn't use complex mathematical models. He used brute force. In the early days of Section T, scientists literally threw these glass tubes against hard concrete floors over and over again to see which ones would crack. They built makeshift cannons out of steel pipes in farm fields, firing the electronic components straight into the dirt to test their resilience against pure, concussive violence. But simply having tough glass wasn't enough. The microscopic filaments inside the tubes would still snap under the terrifying rotational G-force of a naval gun. The breakthrough was a masterstroke of American pragmatism. They decided to cast the entire electronic circuit inside a solid block of protective resin and liquid wax. Once the design was perfected, the challenge shifted from science to mass production. And this is where the sheer scale of the American war machine took over. But the assembly of these intricate, deadly fuses required an unprecedented level of deception. Across the Midwest, inside factories owned by civilian companies like Sylvania, Crosley, and Eastman Kodak, tens of thousands of women were brought onto the assembly lines. Many of them were housewives, former jewelers, and watchmakers. Imagine being a young woman in 1944, sitting at a wooden workbench under a harsh factory light. You are handed tweezers, a magnifying glass, and a soldering iron. The factory foremen tell you that you are building internal components for standard military communication radios, or parts for medical equipment. Day after day, shift after shift, these women meticulously soldered microscopic wires, completely unaware that they were literally holding the salvation of the United States Navy in the palm of their hands. The secrecy surrounding the VT Fuze was so absolute, so ruthlessly enforced, that the American government actively deceived its own citizens to protect it. The women who built the fuses never knew they were building a weapon. They just knew they were doing their part to bring the boys home. The result of their blind, tireless labor was a masterpiece of lethal engineering. When the artillery shell left the barrel of the ship's gun, the rapid spinning activated a small, wet cell battery. The fuse immediately began transmitting a continuous radio wave forward into the empty sky. As the shell approached a Japanese aircraft, those radio waves would strike the metal hull of the enemy plane and bounce back. The moment the fuse detected the returning signal, exactly when the plane was within a lethal 70-foot radius, an electronic switch closed. It didn't need to hit the plane. It didn't need a gunner to guess the right time. It simply sensed the enemy's presence and detonated, sending a massive cloud of jagged steel shrapnel ripping through the thin aluminum armor of the Zero. The Pentagon fully understood that they had created the ultimate weapon of air defense, and they were terrified of losing it. The Joint Chiefs of Staff issued a draconian ironclad directive. The VT Proximity Fuze was strictly forbidden from being fired over land where the enemy could recover it. If the Americans fired it over Europe, and a shell hit the soft mud and failed to detonate, German engineers would inevitably find it. They would easily reverse engineer the technology, equip their own anti-aircraft guns with it, and the mighty Allied bomber fleets that were currently pounding Germany into submission would be wiped out in a matter of weeks. The secret was too dangerous. For most of the war, its use was fiercely restricted to the open ocean. Out on the deep, unforgiving waters of the Pacific, a dud shell wouldn't fall into enemy hands. It would simply sink to the bottom of the ocean, burying America's greatest technological triumph in the dark abyss. By the time the American fleet arrived at the blood-soaked shores of Okinawa in the spring of 1945, the Japanese command was a broken institution. But a broken enemy is often the most dangerous. To protect the massive invasion fleet anchored off the island, the United States Navy established a defensive perimeter unlike anything seen in naval history. They created the radar picket line. These were a ring of lonely, isolated stations situated dozens of miles outward from the main fleet, right in the path of the incoming Japanese airfields. The Navy didn't send massive battleships to man these picket lines. They sent small, lightly armored destroyers. These ships were sent out into the vast, empty ocean with a terrifying double mandate: provide early radar warning of incoming air raids, and act as human bait. They were expected to absorb the first, most violent shock of the Japanese attacks. Take the story of the destroyer USS Laffey, assigned to Radar Picket Station No. 1 on April 16, 1945. For the men aboard the Laffey, there was no place to hide. They were sitting ducks in open water. When their radar screens lit up with a massive swarm of incoming bogies, they knew they were completely on their own. The Japanese hurled a coordinated assault of 22 bombers and fighters directly at the solitary destroyer. The implementation of this kamikaze tactic is often viewed by historians purely through the lens of religious fanaticism and a suicidal devotion to the emperor. But when you look at it through the lens of the American VT Fuze, the kamikaze takes on a different, darker context. It was not just a cult of death. It was a grim, forced evolution. It was an act of absolute, tactical desperation. The Japanese commanders had finally realized that traditional dive bombing was mathematically impossible. Their pilots were being vaporized by the invisible radar fuse before they could even get close enough to see the faces of the American sailors. Since escaping the wall of shrapnel was no longer an option, the only logical, terrifying choice left was to turn the plane itself into the bomb. They reasoned that if a pilot was going to die anyway, he might as well point the nose of the aircraft directly at the deck of an American ship. They hoped that even if the plane was shredded by a proximity fuse in mid-air, its flaming momentum would carry the wreckage straight into the hull. As the swarm descended on the USS Laffey, the American gunners didn't panic. They were no longer the frantic, desperate men of 1942, cranking mechanical computers and firing blindly into the sun. They were confident, methodical, and armed with a weapon that could not be fooled. The Laffey threw up a devastating, continuous wall of proximity-fused shells. The sky turned black with automatic explosions. The VT fuses ground the Kamikaze waves into twisted metal and fire before they could strike. The Laffey took horrific damage that day. She was bombed, strafed, and slammed by aircraft that managed to slip through the sheer volume of the assault. But she survived. She earned the nickname, the ship that would not die. And the men aboard her knew the absolute truth. Without the VT Proximity Fuze, the Laffey, and every other lonely destroyer on the picket line would have been sent to the bottom of the ocean within minutes. When the Empire of Japan finally surrendered on the deck of the USS Missouri, its generals and admirals were a defeated, shattered lot. Many of them went to their graves, never fully comprehending the magic that the Americans had unleashed upon the skies. They spent their final days in power, chasing ghosts, hunting for spies, and cursing the cowardice of their own men. But it wasn't magic, and it wasn't cowardice. It was the triumph of the free mind. It was the ultimate victory of the scientist working late into the night at a university lab, the young woman soldering wires under a magnifying glass on a Midwestern assembly line, and the weary, brave sailor standing tall on a pitching deck in the Pacific. History books usually only carve out the names of admirals, the dates of massive campaigns, and dry, sterile numbers. But real history, the living, proud, and most authentic history, is sitting right there at your own dinner table. If your father or grandfather served on those warships, if they stood under the burning skies of the Pacific, ask them. Listen to the stories they haven't told yet. Those quiet, monumental moments of terror and bravery that never make it into the textbooks. Do not let those priceless memories fade into the silence of time. Please, share your family's legacy down in the comments, so that together we can preserve them for the generations to come. Thank you for watching.